Hello everyone, my name is Ahmet MERT. I'm a second year student at Bilkent University. My department is computer science. Today I will discuss the energy lost while the potential energy is converting to kinetic energy, and I will also discuss that whether this loss can be explained by the work done by friction force or not. In my experiment, I used an air table. It reduces the friction significantly, but it does not eliminate it. So I accepted the coefficient of friction like a small value, 0.01.
In this experiment, I used an air table which provides a nearly frictionless surface for the puck to slide. I also used a ruler to measure the distance between the motion dots, motion paper placed behind the air table, and the timer setting on the air table to determine the time intervals. These pieces of equipment helped me accurately measure displacement, calculate velocity, and analyze the energy transformation. In the experiment, there is a puck on an inclined plane, and when we release the object, the potential energy will convert into the kinetical energy. First step of my experiment is to measure the length of the air table paper. Since I know sine of the inclined plane, with the information I previously had, the length of the air table paper, I calculated the initial height. The second step of the experiment is releasing the puck with zero kinetical energy. Then I measured the length between each dot to calculate the velocity of the puck. With these formulas and the data I received from the experiments, I calculated the initial potential energy, the average velocity, and the energy lost.
In this experiment, I investigated how much energy was lost during the transformation of potential energy into kinetical energy. The puck's initial potential energy was like 0.217 joule, while its final kinetical energy was 0.176 joule. This indicates an energy loss of 0.0257 joule during the motion. To determine whether this loss was only caused by the work friction done, I also calculated the work that friction does on the puck. I used a realistic coefficient of friction, a small coefficient of friction, since the air table reduces the friction significantly. The coefficient of friction is 0.01. The calculated frictional work was 0.02. which is very closely to the measured energy loss. This small difference can be attributed to additional minor factors such as air resistance, or probably calculation errors, or the imperfections on the air table surface. So overall, the experiment demonstrates that although the air table significantly reduces friction, it does not completely eliminate it. Most of the lost mechanical energy can indeed be explained by the small frictional force presented in the system. Therefore, the results support the principle of conservation of energy while highlighting the effects of non-ideal world conditions.